Okay, in the last video we looked at the equals relation. Now we're going to look at the less than relation. So the less than relation, we say that for all x and y in the real numbers, x is related to y via relation L if and only if x is less than y, the less than relation. So the question is this reflexive? Again, L is reflexive if and only if for all x in our domain, which is the real numbers, x is related to, we're using the L relation. X is related to x via our relation. So in other words, is x always going to be less than x? Is 6 less than 6? No. No. So as counterexample, we have 6 less than 6, but we can do another one. Let's do 3 is not less than 3, right? So this is not a reflexive relation. So now we ask ourselves, is the less than relation symmetric? And again, let's recall the definition. We say L is symmetric if and only if for all x and y in the real numbers, if x is related to y, I'll just stick with this less than symbol, less than y, then y is less than x, right? We could also write this as xly, if xly, then ylx. It's the same thing. We're just giving a name, L, to our less than relation. So no, this isn't true, right? And so to prove that, we have a counterexample. Six is less than 7, but 7 is not less than 6. Right? So this is not symmetric. Okay, how about transitive? Is the less than relation transitive? And again, recall that L is transitive if and only if for all x, y, and z in the real numbers, if x is less than y and y is less than z, then x is less than z. And it turns out this is true. And we can see this on a number line. So if I say x is less than y, and y is less than z, so we know that these two, this is the x is less than y, here's the y is less than z, and we can see based on the way a number line works that indeed x is going to be less than z. Now, a better way of, this is an illustration, a better way that I would write this for a little bit more formal of an explanation is this. I would say if x is less than y, then x is to the left of y on the real number line. If y is less than z, then y is to the left of z on the real number line. And therefore, x is to the left of z as well. So x is less than y. And of course this fits if you think of a couple numbers. If 3 is less than 4, and we know 4 is less than 5, we can write it like this. And we know that 3 is less than 5. So that all makes sense. So you might ask yourself, can you think of a relation? Every relation we've seen so far has been transitive, or at least between equality and less than. Can you think of a relation that is not transitive? Well, a good example of a relation that is not transitive is not equals. Right? Because if I say that 5 is not equal to 6, and 6 is not equal to 5, it is not true that 5 is not equal to 5. That makes no sense. Right? So this is not transitive.